about making an application scalable and reliable. When we talk about reliability, we're not necessarily talking about guaranteeing the delivery of a message. There is a technology that Microsoft gives us, part of operating system. They call it Microsoft Message Queuing System. And of course, the name has changed from Windows NT 4.0 to 2000 and now XP. Part of XP, they call it Microsoft Message Queuing on XP. Or on 2000, they call it Microsoft Message Queuing. So there are different licensing, different things for it, but they are part of operating system. In order to make your message queuing available on your operating system, first you have to install the service. By default, if you're installing Windows 2000 or XP, those services are not available. So that for your info. But before even I show you how to install it and take advantage of it, let's talk about what is message queuing anyways. How many of you guys have gone overseas, visited different country? There you go, plenty of you. By the time you were buying your ticket, did you ever hear this question? What type of meal would you like to have? Absolutely. So what happens if by the time you're ordering your ticket, that meal is not available? The airline agency, is it going to stop selling the ticket to you because that kitchen is not available, making that food for you? Obviously, no airline agencies are making that food on their own. They're ordering it from a third party. So imagine you're sitting at your station and you're ordering that ticket online. And then it comes to the time that you have to order your meal. And that section is not connected. In other words, that third-party company, their database is stopped for some reason. So what's the story? Are they going to finish your transaction and charge your credit card and charge you around $1,200 in order to fly to Spain, for example? Or say, sorry, your seafood is not available, and because of that $50 that we can charge you, we're not going to just sell you a ticket. So in this kind of an example, you realize that how important it is in order to provide an asynchronous application. The way it works between your client application and your server application, there should be a mechanism in order to let the client and let the server know that there's nothing wrong, despite the fact that there is a, synchronous problem. In other words, not both applications are running at the same time. You have probably heard about technologies like RPC, remote procedure call, or for example, Windows sockets application that you're writing and communicating over the network. For those kind of technologies, both client and server should be up and running at the same time. But message queuing system is going to be a service that operating system provides to you. And then all you have to do, send your messages, and when I say messages, that would be literally any message. Could be calling another program to execute a shell program, or could be literally an email message, or for example an XML file, anything you want, literally. Or you could just pass an object by the time you're marshalling. That could be a message. Give it to a third-party service, which we know it as MSMQ, or Microsoft Message Queuing System. It's like a mailbox. It's like you go to post office and rent a mailbox, like mailbox, etc., right? So all you have to do, just give that message to them and not to be worried about it. It's like you're sending a gift to your friend for Christmas. You don't have to be worried about if he's home or not. You just give it to the post office, and post office will take care of it for you. Of course, like post office, if your friend is not available ever, what's going to happen? They keep trying and trying and trying, and then they say, sorry, we cannot deliver this message anymore. So they will give it back to you. Well, obviously, the same story is true, part of Microsoft Message Queue. They have a particular location, they call it bad mail, or some sort of a dead letter, or whatever they call it. So there are different queues, and the queuing technology is like a placeholder, is like that, tray that you have on your desk for the incoming letters. Is like a stacking of different messages. So for each message that is coming, the application should know a specific queue and go and open up that queue and process it and keep checking and checking and checking. For those of you who are C++ programmers and you have worked with Windows-based applications, you're already familiar with the concept of message loop. You keep going through different messages, different queues, and trying to read those information one by one. And then finally, you're listening to a quit message, and then you exit the application. The same story is true, but this time, we're not dealing with messages on Windows. We're dealing with generic messages. Microsoft message queuing is not a standard technology that Microsoft invented it. Every vendor, they have their own message queuing. Unix has one, IBM has one, and so forth. But of course, dealing with those message queuing system is not the standard way. You have to understand how to connect to each one of them. So it's not a necessary, generic way of communicating between dissimilar systems or heterogeneous environment between Microsoft or between Unix or Linux or anything like it. But we are right now learning .NET in Windows. And you shouldn't be worried about, oh, what do I do? Shouldn't I use this technology if I want to come and talk to Unix? The answer for that is, yes, of course you can, because you already heard about web services. Have the web service to communicate with your queue on your box, and have a web service on Microsoft to communicate with another web service on Unix, and they both talk to each other. And you literally have an asynchronous system anyways. Since the Microsoft message queue is part of each operating system, again, you have to install it. It doesn't come by default, which I'm going to show you how. And then, after you set it up, all you have to do, create a queue for yourself, or use an existing queue that is already available. Open it up, send a message to it, and have another application to go ahead and read it. I have an application that I'm going to demonstrate it for you in a minute. But before that, let's talk about how to check to see if we do have Microsoft Message Queue on our boxes before we even do this. As you are familiar with the system here, Microsoft has already provided that for you. That would be Microsoft Management Console, which is a blank container. If you open up MMC from run command, there would be a blank container. And of course, how to create a snap-in or a node for your application into this container, that's a totally different chapter and is not going to be covered in any Microsoft courses, I'll tell you that much. But it's not really that difficult. If you're a C++ programmers, you already know that, great. There's an ATL wizard that you can go and, create a skeleton code for that. So if I go down in here and try to open up a particular snap-in that operating system provides, they call it computer management. If I click on add and try to add computer management snap-in here, of course, is allowing me to go ahead and connect to other machines as well if I wanted to. But I'm just going to go with my local and add a snap-in in order to go and manage my own machine. After that, if I expand this node, the third node is going to ask me for services and applications that are available on this box. And as you realize, one node says message queuing. You might or might not have that. If you do not have it, all you have to do, go to Control Panel, from Add and Remove Programs, select Windows Components, and add Microsoft Message Queuing, which is not the portion of this demonstration. I just want you to relax and see me, because that takes a while in order to install it. If you have any other questions later on, any further questions, you can always catch me out of the classroom outside of this session. But right now, if I go ahead and expand this, there are a bunch of different queues that have been categorized into, for example, public sections or private sections and so forth. Public queues, of course, is available throughout the entire applications that are running. And then private is only, related to your application or any other assemblies that you want, and so forth. Of course, this is XP Professional. So you don't have that much of capability of connecting with like remote servers at the same time. You're limited to 10 connections. So keep that in mind. But if you're dealing with like a server, then you have more flexibility. Anyhow, I'm just going to leave this open right now. Actually, I do have it open right here. If I go down here, well, I guess after all, I didn't have it open. I'm going to open it up later on. But let's go into this technology for a second. As far as Microsoft Message Queuing, I've already explained that to you, that what it is just like a third-party utility that Microsoft gives you. And all you have to know about message queuing is how to open it, how to create it, how to delete a queue, how to send, and how to receive message. That's it. You don't have to be worried about the type of a protocol that two machines are running. You don't have to be worried about if the machine is answering you or not. So Microsoft has given you so much of capabilities by just using an existing service. And now .NET gives you the capability in order to take advantage of that. So Microsoft Message Queuing, as I mentioned as a summary, implements message sequencing between different applications. And that gives you the capability not to be worried about both applications are running at the same time. And of course, provides, I wouldn't say guaranteed, I would say reliable. Because guaranteed means that you will be sending that message no matter what. But that's not the case all the time. Because what's going to happen if that application is not there anymore or there's something wrong with that server for a long time? But if you take a look at it in an optimistic way, and as long as the message is staying on the queue and it knows where to send it to, yes, it is guaranteed. But it's going to be a manual guarantee delivery. That means an administrator should go to that particular queue and right-click on that message and say, send it again. Because after a while, it's going to just stay in the dead letter queue. So it depends how you look at this second bullet over here. Guaranteed from what point of view? From manual or human interaction or software application? Software application, I wouldn't call it guaranteed because after a timeout, it's just going to go to the dead letter queue. .NET Framework integrates the message queuing for you in a better way in comparison with unmanaged environment. Just as a reminder, you probably already know about the difference between managed environment and unmanaged environment. Many students think managed environment means garbage collection. That's not the only thing. That's important for you to know. Managed environment is more than garbage collection. It's a lot more than that. Having the same type, having a just-in-time compilation, and lots of other things that you already have gone through it before. I'm not going to just repeat it for you. But right now, .NET Framework, since it sees the message queuing as an internal part, it actually implements it in an easier way. If you are taking some of the sample codes that MSDN provides for you for Visual C++ 6.0 with message queue, you realize that there would be more lines of code that you have to implement in order to achieve the same thing in comparison with .NET, which I'm going to show you in a minute. So, as I mentioned earlier, part of this demonstration, this particular chapter only talks about how to receive a message. Unfortunately, they don't talk about how to send it first. So obviously, you have to have some messages in order to demo this, but just a warning for you, if you want to just go and do this demo, it's not going to work. Okay, I've prepared something for you that you can see it at least. All you have to know, the basic understanding of this chapter is there is a class that Microsoft has created for you. I'm sure that another colleague of mine has already explained the .NET classes for you, or base classes for you. There are over 250,000 functions available on all those classes. And some of them are sealed, you cannot extend, some of them aren't. So this is one of those classes. And what are these classes anyways? You can think about them like a DLL or a component that Microsoft really gathered and wrote them and make it available for you. But one of those namespaces that you're dealing with, part of message queue, is system.messaging. Part of system.messaging, not only you can create a queue on the system, either locally or remotely, all right, and also make it like a transactional or non-transactional, but also you can create messages, and that could be almost any messages. Could be a binary format, could be XML format, could be any format you want. You're free. You could do anything. In order to make the job a little bit easier, we have done it as an XML format. Yes, sir. Absolutely. The question was part of a regular message queuing on managed environment. You were limited in the size of message, but of course, even in that, you could customize the size of a message, even on a managed environment. Just for an info, you could marshal it. You could actually have a customized marshalling, even part of the queue. So you really weren't that limited in that environment. But here, since you're working in language that is common between all languages, you're using CLR. So for that, you're using the same common type library. And because of that, you're capable of sending an object. And that object could be anything as any size. You know it as an object. So operating system and CLR will take care of that. So you don't have that limitation. Yes, sir? message queuing is part of operating system. And if I want to call it free, is not right because you're paying for operating system. But you're not paying additional fee for licensing for it, if that's the question. That's correct. Yes. You do have, actually on 9X you can use it, but on NT environment you have message queuing. Let me correct that. On 9X you can act like a client for MSMQ, but doesn't have a service, because remember that 9X operating systems are not servers, and this is a service. And if you wanted to have some sort of a capability, then you had to have an application running doing the same thing, which is almost impossible. So, but you could have an application on 9X running in order to access a server with MSMQ. Is there further questions? Feel free to ask me anything you wish, okay? So, part of this namespace or system.messaging, you do have some classes, obviously, like any other namespace. One of which is message queue. Obviously, that class allows you to create, check for an existence of it, just in case if you want to keep creating it again, and maybe deleting it, you know, maybe setting some properties for it, putting a timeout interval for it, see how frequently do you want to go and check to see if the available application is still running or not, add an event handler for it, and so forth. That was it for message queuing. And as you realize, there are some demo codes on your book, but good luck with that. Let me show you some demos. Part of this demonstration, as you see, I have created many different applications for you. The first application that I'm going to demonstrate is message queue. And of course, there are two different applications. One is message queue, the other one is message queue receive. I didn't name the other one send, sorry. But Microsoft Message Queue, what it does, it goes and creates a queue for me. And as you see, I've already added a reference to system.messaging, obviously. You didn't even have to do that. You could just drag and drop a control literally from your toolbox and bring a message queue component on your form. That's easy. Actually, let me show you that. Let me go to form main. Part of this form, I didn't want to waste time to develop it right away because it is going to take a while developing these things. I've prepared this, I believe, a few days ago. I don't remember exactly, but as you see, I've created a queue in here, but I'm going to ask you, what do you like? I'm going to ask for a name, and then I'm going to check on the message queuing system to see if you already have it. If you do have it, I'm going to use it. If you don't have it, I'm going to make it, okay? And then here, that would be a message, multi-line, text box that you can just put anything in it and send it. And you have a capability to delete it also. Very basic, functionality. Proof of concept, in other words. All these demos are like that. But one of the tab that you have in here, part of toolboxes, as you see, is message queue. In other words, whatever I'm going to go through today with you is all about this tab. I'm going to talk about components. I'm going to talk about like message queuing, performance counters, and so forth. But not all of them, though, because we don't have time. So, as you see, I've already dragged and dropped a message queue on my form. And that automatically adds adequate references. So many of these tasks that you have to do, you have seen it probably part of previous demonstrations that my colleague has done. You have to go add it manually. You really have to drag and drop it. I mean, we wanted to show different things to you, okay? But let's take a look at the code. If I go to the create queue code, this is pretty big, huh? I didn't think that. Because my resolution first was like 1600 by 1200, and then I thought I should change it. Let's go back and revisit that. Is that better for you? Everybody sees it in the back? Okay, as you see, not to mention that you're a C++ programmer probably, and you're familiar with exception handling. And part of this, I'm using a try-catch block. First question is, this is, by the way, VB. If you're not familiar with Visual Basic, it's too late. I should have known better and make it with C#, at least closer to C. But bear with me and just accept it. Input box is asking you to enter something, and then you're storing it in a string value. I'm asking for a path. And what I'm doing in here, I'm actually concatenating it with a path that is already available on my machine. And dot period backslash would be the machine name. It's like a local machine instead of putting a computer name. The reason I did that because I wanted you, just in case if you download these demos later on off our website, you would be able to run it, not necessarily trying to debug it, So private $ is a shared queue that is available on each machine, right? And is available on both 2000 and XP. So what I'm doing in here, I'm actually creating a temporarily a string builder object. And a string builder object is a cool object that Microsoft has given us, part of .NET. If you have manipulated a string in C++, you know the pain of it. You have to concatenate it, calling different functions and all. But there is a string builder object for you now, part of .NET. Check it out. I've created an instance of a string builder, and all I'm doing, I'm inserting and appending to that string. That's it. And finally, at the end, I'm just converting it into a string. Simple. I didn't have to be worried about, using different things or creating temporary variables or anything like that. And on top of everything else, it doesn't create a string object inside of the memory. So it's a lot quicker. It's just a pointer. Okay, so you're not really creating an object, literally. So it is efficient, is faster, and is easier. Keep that in mind. As you realize, in 4 lines of code, all I'm doing, I'm asking for a name of a queue, and I'm just putting a prefix of dot backslash private $ backslash whatever the name is. Now, since I've already added the message queue object into my form, right in here, I'm creating a new instance of system.messaging.messageQueue with that path. And you have probably heard about creating a component in .NET, but I'm going to show you later on anyways. But one of the things that you could do, you could pass a variable or a string as a construction string to your component. So you could pass almost anything, and by the time the object gets created, could take that as an initialization. So what I'm doing, I'm passing a path into that particular class, creating a new instance of it, and automatically knows you're going to create one. Somebody had a question.
You said that the private queue is a shared queue on every machine.
That's correct. It's hidden shared. That's why you see the $.
So private is not private to the application.
It is private to the application, that's correct. The reason you have it because you have the capability from another machine to create a queue privately for another computer. Not necessarily accessing it. Administratively, you can access it. Programmatically, you have the application, you have no access to it unless you know the actual path.
So you call it shared just because you can access it?
That's correct. I call it share because I can access it. Not necessarily I can do anything with it. I have to know the path, literally, in order to be able to communicate with it, write to it, read from it. So then I create it. You see the difference between the two is first you instantiate it and then you make it. First you know how much memory you need and then you're really creating it, right? Like anything else. Of course, luxurious, I have enabled, disabled some buttons. Obviously, you won't be able to send if you haven't created it yet. Or you won't be able to delete when you haven't made it yet, right? And vice versa. After you made it, you shouldn't be able to make it again, right? Now, of course, I catch any error or any exception that is coming to me. On the send button, as you see, I'm creating a new instance of a message. It's not a message queue, it's a message class. And your message, like any other message, could have a label, could have a body, could have a format name. That means what kind of a format does it have? Like, is it an XML? Is it a binary? What is it? So you can really customize your message. Could be literally anything you want. Could be an object, as we talked about. And of course, so simple. All I'm doing, I'm getting a value of a text box, setting it as the body of that message. Wrap it up. Because I didn't want to waste so much time, right? Of course, you could make it a lot fancier. But the catch here is there's so much of this property setting has been done graphically. I didn't have to set it up programmatically. Let me show you that. If I click on a message queue object, which made the job a lot easier for me, I'm just clicking on that particular component. If I switch back to the property pane over here. As you see, there are a bunch of properties that I have already set, such as formatter. I set the formatter to be XML. So you know what? .NET automatically converts your value into an XML document, literally. It passes it using SOAP technology as an XML. So there you have it. If you guys are familiar with Bestock, if you're familiar with like e-commerce, Commerce 2002, all those fancy names that Microsoft has created it for communication between different applications or different companies and all, you have it ready. You don't have to be worried about learning XML, how to create an XML document. All you have to say, format it to XML. That's it. It gives it to you. It creates a schema for you. You can actually enforce the schema in order to check the actual document to see if it has changed or not, if it's validated or not, just by setting some properties. That's it. Don't want to discuss that a lot, but this is the message formatter, right? So what I'm going to do, I'm just going to execute this, but before that, accidentally I closed that thing, which is the computer management. I'm going to go back to it very quick, and I'm going to add the computer management to it. Actually, you know what? It's quicker for me to go to control panel rather, and get that right off control panel. You could go to control panel and select administrative tools on your XP, of course, because XP by default does not give you administrative program icon. You go to administrative tools, and from administrative tools you can double click on computer management. And part of computer management, the third node, as I mentioned, talks about services. You could actually go ahead and open up the services pane and see the message queuing. I'm just going to leave that open because I wanted you to see the queue that gets created. Patient is a virtue, of course. So if I go down here on the message queuing, on the private message queue, you see I've already created a bunch of queues over here. What I'm going to do, I'm going to get rid of my name over here. I don't have that. Get rid of all the messages. You see, there's no more queue called Sohail, right? Now let's go execute our application. Check this out. Now I have all kinds. All right, let's go and run this application. I'm starting my application, and what it does, it's going to ask me, okay, what's the name of a queue? I'm just going to go make it again. As soon as it comes back up, it compiled it. And now it's going to launch the app. Come up in a second. Of course, I'm running a bunch of different programs. And this is not a weak laptop, by the way. It's very powerful. I'm pretty happy with it, actually. But I'm just running so many things at the same time. By the way, sometimes with Visual Studio .NET 2002, the version that you might be working with, you might see this error. In other words, it's running, but you don't see any form. All you have to do is stop and restart it again. 2003 beta, final beta, is on my actual desktop at the office, and I'm pretty thrilled with it. It's very powerful. So look forward to 2003. If your company has not purchased .NET yet, I would wait a little bit longer or get an update. Yes? Absolutely. Queuing is queuing. That's true. But you got to be careful about that, though. As far as the messages you're sending, as long as those messages can be interpreted by unmanaged environment, you're good. You know what I mean? Because integer is not necessarily integer over there. So keep that in mind. So if I click on create a queue, it's going to ask me, what would you like to name that queue? Just go name it. So yeah. Again, you did not have that before. Right in here. I do not see any Sohail under private queues. And if I go back on my app and click OK, I create the queue, I disable my button, and I'm ready to send messages. Let's first check it out and see if I do have the queue. Obviously, you have to go and refresh, because unfortunately, MMC is not smart enough to understand that you should refresh it frequently. And as you see, this queue is available now. I made it. Of course, you have the capability to delete it as well, but I'm just going to send few messages to it first. I click on queue messages, and as you see, there is no message at the moment. Let's go switch back to my application and try to send some messages. I say welcome as one message. Oops. Welcome. I click send. And then I go back and I say to Apex Infotech as a second message. And I say course 2717 as a third method. Now if I go back in here and refresh my queues, you realize that I have 3 messages, right? I have 3 messages waiting for me. Let's go explore a little bit and take a look at those messages very shortly. Go down in here, double click on one of the messages. As you see, automatically created an ID for me. It specified the time that I've sent it to. It shows the available queues. It identifies me, who am I as a sender, and finally the body of a message. And check it out, it's an XML, because I set an XML formatter. Now, whatever you see, you had to do it manually using Visual C++ 6.0. What did I do? Nothing. Drag, drop, set few properties, call few methods, I'm done. Made it a lot easier. Now, this is half of the way. Let's go back and see how could we retrieve these messages. I'm just going to leave this right in here and switch back to the next demonstration that I've already made for you. I'm not going to delete that, obviously, because I'm going to use it. But you would take my word for it that if I go down in here, and all you have to do, call the delete method of your MSMQ and pass the path, and you're going to be fine. It's going to automatically wipe it out with all the messages in there. So it's dangerous. You've got to be careful about it. Of course, you should go check, get all messages, see if there is no messages, warn it. Otherwise, you shouldn't delete. I didn't do those things for you. So now let's go down and take a look at the receive application. Obviously, the receive application is pretty much the same thing. If I go back to the code, I've already drag and drop a message queue again to it, right? But this time, I have to open a queue. I'm not going to just create it, and then I'm just going to receive a message one at a time. But of course, I've created the list box in here and keep appending items to it in order to show all those messages. So first, let's take a look at behind the scene and see what do we have in here. As before, I'm just asking for a path. I'm concatenating to it, and then I'm going to go and pretty much check for all available queues, part of my local or private queue, and I check to see if the one is matching mine. In other words, you might have more than one private queue. I have to go through all available queues, open them up, check them out. If it's the same, right, I open it. Otherwise, I have to create it. Make sense? And then tell you there is no message in it. Of course, that goes back to your design. Some companies don't want to have, to do anything with creation of it. If you want to open it, you should have it already. So just different approaches. As soon as I found my queue, I'm just going to jump out, and then I'm going to come back in here and make my button that says receive my messages available. So with each click button, what I'm doing, I'm keep adding message to it until I don't have anything. Made it very simple for you, obviously, right? So let's go run this and see what's happening in here. If I go and execute my application, it's going through that program, and it's going to ask me, okay, what particular queue do you want to connect to? And I'm just going to type in my name again, because obviously I have to connect over there. So I say open queue. It's going to ask me where. I'll go with Sohail again. Since it could open it, it didn't give me any error. Now I say get. Check this out. I click once on this button. Okay, let's see. Obviously, it says format name is invalid. Hang on a second. I checked this out. Before I have to check it again to see what's going on. Let me get rid of this extra windows. By the way, let me show you something in here. Here you have time span. This is something else I had to show you. By the time I'm going to receive, I'm creating a new instance of a new time span class. The time span class is like an async object, and check for the second, minutes, and hour. I said 0 hour, 0 minute, only 5 seconds. That means only try this for 5 seconds. And if you reach that and you haven't passed that time yet, throw an exception at me. So that makes it a lot easier for asynchronous programming for you. But just bear with me 1 second. Let me go back in here and just do the compilation. Once again, let me run this. Hopefully it's going to work in here. Otherwise, I'm not going to waste your time. I'm going to go back to it and fix it, see what's going on. I checked it out this morning and it was working fine. Let's go open Q again. Try to get. I have no clue what happened. All right. Probably. Maybe it's not like that. But maybe is I typed in capital S. This time I didn't. Maybe that's the case. So as you see, I got all my messages now. But check this out. Now if I go to MSMQ and refresh, since I received my messages, there are no messages left on the queue. So I just proved it to you that if not both applications are running at the same time, still you can communicate. So that could be like updating your SQL Server database, could be whatever you guys have. And you want to just have like a reliable app. Is there any questions before I move on? Yes, sir. By nature, message queue does not retrieve anything. But if you like to, you can make a copy of it in a queue, in a different queue, not the same queue. That's the nature of message queue. Right. The concept you're looking for is covered in COM+. COM+ allows you to have multicast. You don't have to keep tracking of all available messages. The technology that we use over there is that you are subscribing yourself to a queue, and the queue is smart enough to generate a message as many as subscribe and send them at the same time. You don't have to keep dragging it up and making a big queue. That technology is obsolete. They have like a multicasting technology. COM+ give you that capability that we didn't talk about it. Of course, you shouldn't be worried about it. Yes, sir.
Suppose this queue you can send to another machine. So what protocol is your solve?
That's the whole idea. You don't have to be worried about that. Operating system, as long as they can see each other, they can ping each other, you are fine. You don't care if it's net bias. You don't care if it's TCP/IP. You do not care. You have to be able to communicate with the other machine. If you can, this is working. Then you have to take that into consideration. If you are using MSMQ, you have to go read the documentation and have your administrators to open that port for you. Is for intranet applications, that's correct. Again, you have to open up those ports that are necessary. It really depends.
Because those messages showed up in the MSMQ, I'm kind of suspicious that maybe this type of message queuing is not meant for like a lot of data, like a high-speed amount of traffic.
These are data that we are talking. These messages are not literally data. They are commands between applications. If you want to have like a data to be transmitted, obviously you have databases. You have SQL Server applications. You have distributed transaction coordination on it. These are only for communication between applications. In other words, you might have an object that you wanted to transmit. What is that object? What data is it? Is it like a document you want to send? So you really don't have it as long as As long as you send the message, obviously the other application comes up. If you want reliability with zero delay, obviously MSMQing is not a good technology. You have to make sure both applications are running at the same time. MSMQ is for asynchronous programming, asynchronous environment. That means there is no guarantee that both applications are running at the same time. So if that's an environment, then you have to understand what's the delay. Then you have to go adjust your queues to see how long you want to keep the messages. Then you have to understand how much space do you need on it. How big of a message do you want to send? So there are a lot more to this than this demonstration, really. There are some courses, if you want to take like MSMQing technology, there's a 3-day course only for Visual C++ 6.0. Then you want to do it in .NET, there's a course 2557, which takes 5 days. You want to do it in Visual Basic, there's a 5-day course for that. So it really depends what is it that you want to do. Then you have to manage it differently.
How fast is it? In other words, let's say both applications are up, and there's comparable. How fast is message queuing to other transports or?
Okay, I have to divide that answer into 2 different sections. As far as the speed, MSMQ, as soon as you open it and you say receive, instantly tries to reply back to you. But how long does it take you to receive it? That goes back to your network. So I don't know what to tell you. It really depends on your bandwidth.
Yeah, but overhead and such, let's say, comparing COM to message queuing.
Message queuing is COM. It is COM, internal COM that Microsoft wrote for you. So, but since it's an internal, it's not as bad as COM. It's a little bit faster, specifically in .NET. It is part of .NET framework. Is there any other questions? Okay, the next section talks about pretty much robust applications or performance counters and event log. Again, there is no demonstration for performance counters. How many of you have worked with operating system heavily? Like you can understand what is performance counter and all. Okay, I would say half of the class. Let me explain for the other half that what is performance counter, right? Operating system automatically gives you a bunch of different objects, and for each object Microsoft has given you some counters. That's part of WMI, which I'm not going to get into it by detail because we don't have time. But consider old days back in like early 80s. If you have been doing programming back then, you remember the old dark days that you had to, have a support for each printer manufacturing your application. And they were coming with a new version. You were totally toast. You had to have a support for it too. And then Microsoft and other community, they put a stop in it. They said all OEMs are responsible in order to write device driver to particular interfaces, and all programmers, all they have to do, call those interfaces. So operating system acted like an intermediary component between printer manufacturers and software developers. So that's why all you have to do now, say, print automatically opens up a print dialog box and shows whatever printers you have. You don't care if they have X printer, Y printer, or Z printer, right? They're going to just open up whatever printer is available. The same story is true, part of WMI. I just said it very quickly with that analogy. WMI stands for Windows Management Instrumentation. That means any program that you have, and I didn't say hardware, did I? I said any program that you have, all the interfaces, all the classes, all the methods, got to be exposed to other programs and applications by default. But again, who is listening? If you're a company that you want to sell your software, you have to follow WMI standard. But if you're like a small company, you just do a project here and project over there, you might not care for it, right? So Microsoft, since is giant, they automatically make everything WMI compliant. That means if you're installing SQL Server, Exchange Server, IAS, MSMQ, whatever you put in there, there is a counter and there is an object associated with it, part of WMI. And what do you want to do with it anyways? You can monitor them, you can see what's wrong with them, you can check them out, or you can create your own kind of a management program for it. Did you know, like there are some tools like SQL, that if you don't want to use Enterprise Manager, you can write your own thing and pay less to Microsoft. Or SMS is $40,000 for, I don't know, 20, 30 user license. You don't like it? Go write your own. It's going to be like $5,000 for that many people. As long as you use HTTP protocol, you can write some sort of a program for yourself and make it a lot cheaper. You're a programmer, right? So that's why Open Software Foundation, they actually enforce companies in order to use WMI. Enough of that introduction. Performance counters are counters for each object that you install on your machine. And they're available for you. What you can do with them, you can check to see what's going on. You could actually log them. You could check for a particular measurement and based on that take adequate action. Like for example, you want to install an application. Let's say you have an application. I heard you guys make Disk Keeper, right? Okay, imagine you have a third-party Disk Keeper and you want to sell it to somebody. I buy your program. Your program should check my disk space, for example, to see if I have this much disk space available, then I can install myself. Otherwise, I'm not going to just do it. I'm not just going to say, oh, you don't have enough hard disk space at the middle of my progress bar. That's the old way of doing things. Make your program smarter. How do we do it? We go check the disk object, and we look for a counter says free page or free bytes or whatever. If it's matching my number, then I can just prompt you, say, yeah, I can go on, or I don't let you even install me. You know what I mean? Make your setup even smarter. That was one of the examples. Or your program requires SQL Server. SQL Server to be running at all time. Well, if your program realizes that SQL Server is not running anymore, what are you going to do? Are you going to wait for someone to do something in your application and then you throw exception out? Or you just want to suddenly warn or email or do something or page someone, say something has happened without you get the exception? You know, that would be a smart services that world is going after, right? That's what you're here for. You want to learn these things. So performance counters are available. In order to get them, you could again go to control panel. And part of control panel, there is a particular item in here. They call it performance counter. Let me find it for you. It should be here. Do you guys see it by any chance? I am in administrative tools. Do you guys see it on yours? Oh, there you go. I was just blind for a minute. On the performance, if I open that up, you guys are welcome to open it up as well at the same time. Part of this particular object let me get rid of extra items in here. Part of this MMC, as you see, I have by default a chart view. It's like a health monitor. By default, there are a bunch of objects and counters that I'm monitoring. I don't want to get into the detail of this, all right? Just wanted to show you some capability and functionality. If I add on this plus sign, I'm adding a particular object. You see, this is a management tool that Windows administrators are accessing it, and there are a bunch of classes for them. But what you can do, you can go and search for every object that is available and then check for their counters. If you're not familiar with them, Microsoft gives you an explanation. For example, for the processor, there are available counters for you. You don't know what is this, you can click on explain, and it's just going to tell you what it is. So I leave that to you to go and get educated on that, all right? Maybe your application requires to do something with these objects and counters, so at least you know where to go and do it manually. My goal here is to show you how to do this programmatically using .NET. And instead of coming here to the performance and check it out on your own, you could have your code to be smart in order to do these things. Again, this is like an example of performance monitor. However, this is just monitoring as the name indicates. If I switch the view or go down in here on the performance logs and alerts, you could also have pretty much the information to be logged into a database file or a file, a text file or something for future analysis. Or you could pretty much have somebody to alert you, like send you a Windows message or email you or beep you or do something. So the alert log allows you to check for a particular condition, and if that condition violates or go above or below a particular measurement or baseline that you're looking for, and let you know something has happened. So if I click on an alert over here for a second, if I go ahead and set the new alert setting, call it test, I can pretty much check for a specific object. You see that I can add, it comes back in here and asks me, okay, what object, what counter? I say, okay, just accept the default. Just wanted to show you that for a second. I added this object and counter, and then I can say, check the value. If it's over or below a particular value that I'm looking for, then take a particular action. And that action could be, for example, anything I want. Of course, I have to set a value, whatever I put in here in order to get to the second tab. I can log an entry, I can send a network message, I can start performance data log, I can run a particular program, I could do anything I want. These are graphical administrative tools that Microsoft gives you. However, enough of that, let's switch back here to my .NET program that I demonstrated before, and I'm just going to do it again. I'm done with this message queuing now. Let's go to performance counter. Now let's go and take a look at this program. That's a very simple program that demonstrates few things. Of course, the next two sections are event log, which I'm going to show you that as well. All I'm doing, I'm just going to get an object info. And my object info is a particular object I just picked, and then I'm showing different counters for it. That's it. Let's take a look at an object info that I'm looking for all objects. I'm getting like events, I'm getting like mutexes, processes, and so forth, which you are familiar with. Since I realize you were C++ programmers, that would make more sense to you, right? So you want to see all available mutexes, for example. How many mutexes do you have at the moment? Or how many processes are running at the moment, right? You didn't have to call any API function calls, did you? All you have to do, call performance counter class. That's it. And I'm going to show you how did I do it. If I click on object info, it's going to tell me general object information and bring up like 3 objects that I've picked, and then simply it's going to show you and counts how many are they. Just 4 lines of code did it for me. No wonder my laptop is a little slow, right? So I'm running 66 processes, of course, and since you're a C++ programmers, you already know you get a handle of any of those processes, you can do anything with them. Yes? Oh, you want this code? Okay, $100,000 for it. Don't worry about it. As I mentioned, you came a little bit late, I think. I said that I will make all these codes available in our website. You're welcome to download them. All right, don't worry about it. These are for everybody. These are public. Don't worry. I'll make that available. Yes? Yes, that was the next section I was going to. You can create your own performance counter, your own object, and have your application to check for few things that you set. Absolutely. And make that as a documentation for your customers and have them to check for your counters. You can install it by the time you're installing your application. Obviously, those objects like SQL Server objects weren't available. SQL Server installation made them available. Absolutely. But forgive me, because of time, I'm not going to do that right now. Any other questions? All right. The next section talks about events. Of course, time is running by, and I have to move a little bit faster. I know these are all fancy and dandy, but you are here for calm, I think, and that's why I'm going to spend more time over there. I'm going to spend 7 more minutes on this chapter, and then I give you some time for a break, and then we're going to come back and I do interoperability. Okay? So let's get into event logs. Event logs, obviously, are pretty handy for administrators. Because remember, after all, you're a programmer, and you're not on each machine to find out, oh, what is the log? Have you realized the new feature that IE has? It says, send this error to Microsoft. Okay, you could do something like that for your own application. You could gather the data and email it back to you, but sometimes people don't like that, right? You don't want to collect information. They feel like insecure when you do that. What do you want to send? So you could have it for your internal testing at least to see what's going on in your QA environment. You could do that. You could actually gather all this information and send it to a particular location. Or if nothing is happening like that, you could actually have a centralized event log on a server and log that event over there. You could do that. Obviously, the concept of an event log is been around for a long time, starting from NT 3.5, I think, 3.51. Now, if I go back and show you the event log over here, by default, there are 3 or more logs available. If you have DNS, you're going to have DNS log. If you have DHCP, you're going to have DHCP log. But by default, in NT also, you have 3 logs. Application, then you have system, and then security. Application deals with all applications that are running, right? Mostly any exception error handling that you get or any problems that you face with applications are going to be storing themselves over there. Then you have for system, obviously relates to operating system problems. Like there's a service not running or running, there's a problem with that. And then security talks about auditing. Like you want to audit to see who's accessing what or who has logged on or not logged on, or if they're not supposed to log on at this time, you could audit them. You can create your own logs, which I did right now. I created a log called Sohail, and I passed like 2 information to it. Let's take a look at the code. Again, the same application that I demonstrated for performance counter, which you have the code in here. The same exact application talks about log event. I'm just going to change the code a little bit because I've already created Sohail log. I'm going to just make it, your company's name, whatever it is. So if I go down in here, it says enter your event log name, right? I'm asking, what is it that you want to make? And then simply I check to see if that log exists. I'm not going to make it. If it's not, I'm going to make it. I'm going to create a source, and then here I'm setting my event log object, which I've already created an instance of my log, which is an event log now. Whatever I showed you over there, now I can programmatically manipulate. I'm setting that source to be my log name, and then I'm using this write entry, and I write something to it, and whatever it is. Of course, there are a bunch of different properties you can pass. Is it informational? Is that warning? Is that error? Don't want to get into the detail of them. I'm going to show this more by the time I'm going to show you a small little gift, which is Windows services, which you have to learn it in C++ courses. But I'm just going to show you how easy it has become to do it in VB now. So let's go and run this. Actually, I have already made it running. All I have to do, let me go and put this text box, call it, for example, let's put 2:55 p.m. Friday, February, for example, 7, 2003, Apex, Infotech. Okay? And then I say log event. What is your log event name? ESI. That would be your company name. You are our guest here at Apex. Let's go in here and click OK. Believe it or not, all I have to do, switch back here to event log. Oops. Let's do a refresh. Unfortunately, there is no refresh for my event log here. I cannot actually do it that way. So what I have to do, I have to close this, and I have to go back to control panel. As always, sometimes Microsoft forget to add a small little feature for you. F5 does work? Okay. Actually, let's see. Why didn't I make it? You should be able to make the... Actually, you know what? It did not make my source. Oh, I forgot to change my source. I still look for Sohail, and it's not there, so it puts it on the application. But it added an information for me. So as long as I have this, I'm happy. But I could have changed my source, and then that source could have been a new sync. In other words, the new log that you could add into it, like I did for Sohail. As you see, there we go. This is the ESI, obviously. This is information. And 2:55 p.m., Friday, February 7th, 2003, Apex Infotech. You could add any message into it. Now you know how operating system really generates these things for you. And based on that, you could have a log and have it to be, I don't know, search by performance counter, as I showed you before, check for a particular log, check for a particular ID, or you could actually set different categories for it, you know, add an event ID to it, and only search for a specific ID and filter it out. You could really search for a particular ID. You don't have to go through thousands of different messages to do something. And if you found it, then you can trigger something. You know what I mean? You could check for a particular event and based on that, do something. That was a demonstration about event logs. And of course, I showed you that one also. Let's see, what else do we have in here? The last section that this particular chapter talks about is Windows services. Before I get there, they're talking about tracing and debugging. You guys are already familiar with debug.assert. The same is true here. You have it in .NET. Actually, this is an add-on that Microsoft has given to VB and C# programmers. You guys already had it. However, there's a trace object that is already built in part of .NET Framework. All you have to do, by the time you're compiling it, you have to make that trace to be embedded within your actual release binary. In other words, using the release version of your .NET component, you could have trace capability at the runtime. In other words, before you had the release version versus debug version, then release version was bad, then you had to go back and check it out with debug version. That wasn't really good. Now you could really have the release application to generate some problems. All you have to do, you could just go to the application.config, set few options on, like trace enabled, and then have the application really start using their trace object. And then they can start showing you some information. I'm not going to get into the detail of debugging. It's a huge concept. Just wanted to let you know for CE.NET or embedded environment, if you're going to design .NET components or .NET applications for embedded solutions, there is a new interface. They call it EXDI. And EXDI is fantastic. I'm not sure if Microsoft is going to add that part of XP 2003 at all, but what it does, it gives you an interface that you literally can have a symbolic item of your application. Even though if it's hang, all you have to do, you can connect it from another machine and receive all those trace and exception errors, and remotely you can fix them. You could literally do that for any application, any device drivers, anything you want, and is a really a good gift for embedded developers. But I don't know if they're going to do it for operating system on a desktop yet, but it's fantastic. The name is EXDI. Go over the internet, read about it. It's very, very powerful. So using the debug or trace, you could actually now go about and trying to on or make them off remotely from another machine or without even recompiling your code really. And there is a trace object that you can actually add it part of your code, and if you do it part of the trace, part of the release is not going to do anything because it's released, but at the release time or runtime, you can make it on or off by having a switch, which is an XML file anyways. I don't have any demo for that. I have a demo for Windows services for you. The reason I don't have a demo because creating a problem for a demonstration takes a lot longer than trying to fix a problem. You know that. So as far as the Windows services, first let's talk about what is a service. What is a service? Why don't you guys tell me? That's correct. In other words, the definition of a service is a program that starts with, operating system without any user interaction, and since it should start with a particular credential, you have to associate a user account with that service. There we go. Your product already using services. So the services that you were working with, you had to design and create them in C++ at the time. Now, there's a new template that Visual Studio.NET gives you, and that is Windows services using either Visual Basic.NET or C#. Let's check this out. First you have to come down in here and select a template called Windows Services. I've chosen VB for this demonstration. Part of this, Microsoft gives me a service. What I've done, I added a timer component. Oh, actually, it is an application template. You can actually, let me stop this program for a second. As you remembered, by the time you wanted to create a new project, there are a bunch of templates available for you. One of the templates here is Windows Services, right in here. I've already added that Windows service for you. And of course, it's going to give you a service.vb. I don't know if you have seen the demonstration for web services yet, but very similar. That's web service, this is Windows service, right? That's over the internet, this is over the desktop. The same. It's giving you a designer. And that designer allows you to add and insert components in it. Many people think that since it's a designer, I can add almost anything to it. But you got to think. You're not going to give it the visual tools. Like, you're not going to put text boxes or form in there, all right? It's a service after all. Remember that. Well, the question here is, can my service be visualized? Yes, absolutely. Like SQL Server service. That tray, you double click on it, it's going to pop up with a form, and then you can start, pause, you could do anything. But it is a service, right? It's not an application. Of course it can. But you've got to be careful about some of those messages that you're passing. You don't show message boxes from service because it's not supposed to wait for someone, right? I mean, is it any verses from God that it says you can't? Of course you can, but you shouldn't. You've got to be careful about designing a service. So now, what I've done, I've added a timer object. I set few, properties like every 5 seconds, try to elapse. And what I'm doing now, if I double click on timer, what I've done within the timer for each click, for each tick, in other words, guess what? I'm logging an info. I show the actual time. I just wanted to show you a real usage of event log. My service logs an event every few seconds. You know what I mean? But this is the usage of a service. But what is a service anyways? You see, the service itself is going to give me the skeleton code. It's going to give me an on a start and on a stop. And of course, you could do lots of different things. You could say, oh, can I pause? Can I stop? Can I start? You could check for many different things. But I just wanted to make it simple. All I'm doing, as soon as my service starts, I enable my timer. As soon as it stops, I disable my timer. The actual work is going to be done where? On my literally function that I designed. I didn't have to be worried about the service skeleton at all. That made it a lot easier in order to create a service for me. So after you designed everything, you got to go back here to the service.design, and then you had to pretty much right-click and say add installer, which I've already done. By selecting add installer, Microsoft automatically give you pretty much. Actually, I've already done it, so I'm just going to get rid of this. I just wanted to come back in here. It's going to give me service process and service installer. Obviously, you need one service in order to install that service to that operating system, and the other one is controlling the behavior of it. So the service installer literally allows you to install your service to the operating system, and service process installer is like a proxy stub that allows you to be controlled by the service manager, which is located in the control panel. Start, stop, pause. Yes?
Since .NET is being redistributed to earlier operating systems like NT4 and stuff, is there any compatibility problem with these sorts of installers if I wanted to install it on it?
If you have .NET Framework, no. Right. Yes, it does then. Because the skeleton is totally different. If you wanted to have an unmanaged service, I would say, you should use C++ services. But they do the same thing anyways. But as far as like interfaces that they are using in order to control the service with the service control manager, or actually they have a very funny name, they call it SCUM, SCUM, right? If you wanted to control it with NT, this service is not going to be installed the same way. Honestly, with you, I haven't tried it. You can give it a chance, try it out. But I don't think you're going to have that much of a fun time in installing it.
You install .NET Framework on NT4.
Right.
And then you run your service. It should work.
Absolutely, it does work. It's guaranteed that it does work. So, yes.
Can I post a COM object within this service so that somebody can connect?
You can do anything within your service. You can do anything you want. You can instantiate the COM, you could go, open up Excel, populate the cell, you could draw a bitmap, you could do anything you want. You can connect to MSMQ, you could do the log event as I showed you, anything you like. All you're doing is no one double clicks on you. You're running it on your own. That's the catch. But the rest of the things you want to do, you're free to do it.
But not on 9x.
9x does not support services. That's right. Even though you put .NET Framework on it, which you can't. Yes? Performance of a service. What do you think? Is an operating system service? What's that? Say it again, please. Oh, you're comparing the unmanaged service with managed environment? Well, I wouldn't call my service a managed service anymore. It is a service. They made the job easier in order to create it and communicate. All right, so you're asking me if I have a C++ service that runs on NT, for example, or 2000, or if I have .NET Framework. It really depends what is it that you're doing with that service. If it's doing exact same thing, you should be the judge of it. You have to do the profiling. But it shouldn't matter, really. The creation of a service is easier now. And installation is easier. But what you're doing in there is irrelevant for both unmanaged and managed. But again, if within a service you do garbage collection, it would be slower than an unmanaged environment, obviously, right? The basic programming goes back to the same thing I've been learning so far. It's just the logistic I'm showing you how it's happened. What are the differences? Any other questions? So after I did that, I'm going to build my service, all right? I'm building my service. There is a utility. You really have to monitor this right now. Pay attention. There is a command prompt, as you have heard about it before, right? The command prompt of Visual Studio.NET, which has already registered some environmental settings. You open that up. You go to a particular location. Anywhere that you want to be doesn't matter, but you got to be in here. Under your, I'm just going to tell you right now. Actually, let me go make this a little bit bigger so you guys can see it. Everybody sees it in the back. Yes? I'm reading it for you. It's under your operating system, Windows, or WinNT, wherever you have it installed, your .NET Framework, under Microsoft.NET Framework, the latest version you guys have, all right? There is a utility called install-util. Install-util is the name of the utility and is under .NET Framework, whatever version you guys have. Version 1 or version whatever, 1.1. In the future releases, it's going to be the same place. Install-util is a utility that you're literally using in order to install your Windows services with. All right? So far, so good? All you're doing, you're using that, and then you use the path for your service, which is an exe now, and then you run it. And that will give you a service. Let me show you. This is the service that I've already created it. I'm going to delete this. How do I delete it? You use the same utility using /u on install. Let's check it out. Let's go down in here. As you see, I have -u in order to uninstall it. I'm just going to go run it. Obviously, you cannot uninstall a service that is running. Okay, check that out. Now you know why I had a 1600 by 1200 resolution. But for you to see in the back, I had to change this, right? So as you see, the uninstall has completed. Let's check this out. If I go down in here to services, all I have to do, refresh. And it's gone. That service does not exist anymore. Before I install it again, let's go back to my code. Remember about the service installer. I've already named my service whatever I want. Sohail Timer service. You can name it anything you want. That's a display name. That's the name that you're going to see on that services control panel. Right? You could name your service literally whatever service you like also. And also part of the service processing installer, I also specified the account that I would like to match with my service. In other words, I would like to use that account in order to start up my service. You could literally change anything you want. But of course, after you install it, you could do it, administratively as well. You can go to the service control manager, go to the properties and everything else. Did I do anything else, really? I added the timer, did whatever I wanted to do. On a start, I started, and on a stop, I stopped my timer. That's all I did. I did not implement the property pages. I did not call the SCOM. I did not do anything. Now, all I have to do, build my application, which I've already done. Didn't want to, waste so much time. Come back over here, and then install it with install util. And check this out. Installed completely. Switch back to the services. All I have to do, refresh. And now, of course, Sohail Timer service is already there. Now, obviously, within this service, I'm logging every 5 seconds a message to the application log. Let's go prove that is really working. In order to do that, I need a help from event log. Okay, let's go back in here, open up the event viewer, get rid of this guy. I'm going to launch event viewer before I start my service for you to see that there would be a message generated part of the application log. I'm going to get rid of all my application log events, clear all events, and say no, I don't want to save them. There is no application log at the moment. If I go ahead and start my service right now, first, before I start it, if I go to the property page of this service that I wrote using .NET now, I didn't write any code in order to implement this property page for me. But it's taking advantage of SCOM property pages. Why? Because .NET automatically takes advantage of those interfaces for you. Isn't it nice? So, you could associate logon accounts if you like to. You could, take adequate action based on a recovery. What is it that you want to do? If the service got stopped, started, or whatever you want to do. And of course, you could associate this service with other services, doing the dependency. I didn't want to get into the detail of them. All I'm doing, I'm saying, okay, this is great. Let's go ahead and start it. I'm starting my service now. My timer service gets started, and now I want you to check the event log in here. Sohail service has logged an event, and every 5 seconds, I keep refreshing. You can check it out that every 5 seconds, I have a new event gets logged. 12 seconds, 17, 20 seconds, and so 20 seconds, and so forth. So that's my service. It keeps doing it until I stop my service. Check this out. If I go down in here and stop it, I'm stopping my service. And you see it stopped at 3:10:44. Let's wait a few seconds and restart it. Obviously, the next should have been 49 because every 5 seconds I'm logging, but that's not the case anymore, because the service has stopped my timer, so I'm not logging anymore. Now if I go back in here and start it again, you realize that as soon as the service gets started, I got it at 3:11:11, which is more than 5 seconds. That was my demonstration for you. In order not to get full of messages within my application log, I'm just going to stop this, and I will give you the last demo. There is no demo actually, the last section of this chapter, and give you some time for break. The last section talks about application testing. There's 2 tests that you can actually set. I'm talking desktop. There are over 15 different tests using embedded systems. But one of the tests you have, they call it application Center. Application Center is designed for web applications or web services in general. And specifically, if you have Application Center back office product. Are you familiar with the Application Center? I do recommend you to go to our website, and which is www.oneapex.com. There is a button or there is a link in there. They call it Class Test Drive. Please go there. We have spent thousands of dollars, spending so much money and time in order to bring up some of those technologies in a multimedia for you, free of charge. All you have to go there, register, sign up, and see the videos. There are a bunch of videos available. One of them is about Bestock server, SQL server. You can go spend like half an hour, learn a new technology instead of searching over the web. Anyhow, Application Center is a back office product that provides software clustering for you. If the web server goes down, automatically it makes another web server to be available, or does load balancing for you. Anyhow, the Application Center test not only allows you to test your web services and web servers for reliability, but also checks and lets you create an application in .NET that is ready for fault tolerance. So that's one of the utilities that Microsoft gives you. The other one is Application Analyzer. In other words, you can go ahead and run a program and have the Application Analyzer to analyze your app, and literally gets to the point of a function and tells you how much time you had to spend for this process in this method. You can actually gather pretty much all the events that are available, COM plus, message queuing, anything that operating system does, anything your application does can be captured and gets logged into a particular database. And then you can actually monitor. So there you have the end of your discussion about, if this section of the code should be rewritten or not, because you can prove it that that's the most delay time or bottleneck in your code. Analyzer performs that operation for you. Again, I don't have any demonstration for that. There are other courses for those. It takes so much time. That's why I didn't prepare that for you. This is the end of discussion for chapter 10. I'm going to give you some time for a break. Maybe 5 minutes, you come back, then I go through 14 and 15 right after each other.